Howdy, everybody. Hope you're doing well wherever, whenever you are. We're here for day 13 of Advent of Code 2016. Yesterday felt a little bit easier than today's, the previous day's puzzle. So that was good. Yeah, I don't know what it was about that previous day, I guess. Probably just felt a little slow, sluggish. So anyway, energize up. Maybe I ought to listen to some music in the background that keeps me going. I don't know. But yeah, love your comments, love your thoughts. Just by the way, too, I think you can make comments in gists, and you can also do forks, and I'll see your forks so I can see your code. So if you're interested in doing that, I'd love to see them for these days, right? So with that, let's just go ahead and get started. A maze of twisty little cubicles. You arrive at the first floor of this new building to discover a much less welcoming environment than the shiny atrium of the last one. Instead, you are in a maze of twisty little cubicles all alike. Every location in this area is addressed by a pair of non-negative integers xy. This is feeling like a graph problem, right? Each such coordinate is either shortest path thing. Each such coordinate is either a wall or an open space. You can't move diagonally. The cube starts at 0, 0 and seems to extend infinitely toward positive x and y. Negative values are invalid as they represent a location outside the building. You're in a small waiting area at 1, 1. While it seems chaotic, a nearby morale-boosting poster explains the layout is actually quite logical. You can determine whether a given XY coordinate will be a wall or an open space using a simple system. Solve this big problem. Add the officer designer's favorite number, your puzzle input. Find the binary representation of that sum. Count the number of bits that are 1. If it's even, it's an open wall. If it's if it's even, it's open. If it's odd, it's a wall. Okay, so this is an interesting one because it sounds like we have a grid, but the grid is infinite, but not negative. Yeah, okay. So the grid's always expanding this way. It could go as far as you needed, and you just calculate what it is based on this. For example, if the office designer's favorite number were 10, drawing the walls as hashes and the spaces as dots, the corner of the building containing 0, 0 would look like this. And it gives you a grid. Suppose you wanted to reach 7, 4. The shortest route you could take is marked as 0. Okay, yeah, you start at 1, 1, and you want to go to 7, 4. And this is the shortest path. Okay. Thus, reaching 7, 4 would take a minimum of 11 steps, starting from your current location, 1, 1. What is the fewest number of steps required for you to reach? 31, 39. And your puzzle input is 1362. Okay, yeah, this is just the pathfinding problem, right? Because the steps are always 1, it's a BFS. I mean, Dijkstra's, if the distance is 1, you're essentially doing a BFS because it's going to try all the routes. I'm sure I've said that before, haven't I? So we can implement the BFS ourselves, or we could try the pathfinding. It won't be hard. Let's just implement it ourselves. See if we can't. Maybe that was, I think one of the days we did the BFS, it felt slow, but it wasn't slow because of this. So the interesting thing that we need is this, and we need to remember we start at 1, 1. Right? Like we're going to have some function that's going to calculate this. And we start at, so let's just put that here. Let start equals 1 1. Okay. Find. So we got to solve this. What is our input going to be? It's just going to be a U size. That's how we're going to parse our input. How could that possibly fail? Okay, I just had to trim the white space. So let's start by solving this, because this is going to be like our is success function. Oh, and we might maybe create like some points so we can do some arithmetic. So struct point x u size y u size simple point. Let's see. We're gonna do tests on these things. We need to derive, probably debug. Hash equal partial equal. We'll probably need those. That. Okay, so we do this. So can we do this like point x y equals self? Almost. Does this work? Yeah, it looks like it does. Okay. So let n equal x time x time. I'm inclined to just copy and paste here. So we have that. We do the weird math. Is there a way to get the bits in Rust? I mean, I know you can just do the bits. Oh, there is a built-in count ones. Okay. So it's n dot count ones is multiple of 2. Is that right? What was if the number of bit I actually have it right here. If the number of bits is even, it's an open space. If it's odd, it's a wall. So it's not this, right? Is that the right one? Is it is multiple of? I'm just gonna look it up really fast over here. It's what Clippy kept telling me. Returns true if the integer multiple of RHS and false. Yeah, I think this is it, right? Because it used to be you do it the other way. Okay, I'm not going to overthink it. Okay, so we want to do a neighbors function. And so we're gonna go just left, right, up, down. So we go negative 1, 0, 1, 0, 0, negative 1, and 0, 1. I guess I can do it like this. Well, let's do it in the for loop first, and we can fix it. So we create a new point with these values. How do I want to do this? I'm not doing diagonals. Like, I don't want to go negative is the problem. Like, if I do 0 minus 1, it's going to overflow, right? There's probably an easier way to do this, but we can just say, like, if x or sorry, if self.x is greater than 0, then if self.y is greater than 0. It's just the greater than zeros actually that matter, right? In this case, I know I can add neighbors dot push point new x minus 1 y minus 1. Oh no, if x is 0, I can push this one. Right? And then I can do their pluses. Filter. So let's just remove all of them that aren't walls. What doesn't it like here? Oh, this is I have to do like and then I have to impl clone here. Yeah, like that's a lot of work, but I think it'll still work. We won't worry about it. Then, so our neighbor's function is if x is greater than 0, we know we can subtract. If y is greater than 0, we know we can subtract. Otherwise, we definitely can add our pluses, right? Because it goes on forever in either direction. So this is the equivalent of going up, going left, going down, going right. So those are our neighbors, and we filter where they're not walls. So we can actually do it with tin to see. For the input, like, because it says if it were 10, we know the shortest, it would take 11 steps to get to 7.4. Okay. Oh, that's right. I didn't calculate that into my wall function. What was that? Add the officer's favorite number, your fuzzle. So we need to add that to our wall function. Like that. Now why isn't it like this? What did I do? Get rid of clone on accident? Okay. So we'll start at 7.4. And we want, yeah, 7.4, and we want the answer to be 11 is our hope. So we do let visited equal fx hash set new. That's going to be in and let frontier is a back deck point u size because we want to track like the distance equal to vecdeck new. This is default, and then we want to visited dot insert start clone frontier dot push back start dot clone 1, no 0, we were there before, so 4, actually it's while let sum p like point cost, or what is it, steps equal frontier dot up front. So this is the BFS part of it. We pop from the front, push to the back. So we say if point equals end, we return steps because we found it. Otherwise, oops, these need to be mutable. Now what do we need to do? We need to like for neighbor in dot neighbors input. Actually, we're going to do 10 first, right? Yeah, we're going to start at 10 just to make sure this works. For neighbor in point dot neighbors. So for each of the neighbors, we know they're valid. So we say if visited insert. I can never remember this neighbor. It returns false if it's already there. So if it's not there, we want to add it to our list. We'll say frontier dot push back neighbor steps +1, like that. Gotta clone this one. Why are you still not happy? Here too. Okay. $11. It's there. It's ugly though. Okay, so that was what we wanted though, right? 11. So now if we do, now we want to look for 3139. And we want to do our input for this one. Like this. 82 steps. Is that it? That's the right answer. Okay. So for part one, not too bad. We just had to implement the neighbors function, determine if it's a wall or not. Spend a lot of time thinking about this. I need to just get used to using these functions. Count ones was new. Is multiple of is like the modulus 2 equals 0. The neighbors, I kind of overthought. At first I was thinking like, oh, I can go forward or backward. So, okay. Next, part 2. What do you say? How many locations, distinct XY coordinates, including your starting location, can you reach in at most 50 steps? How many distinct locations in 50 steps? I think that is just, we still do this, but once steps equals 51, it's our visited count, right? The visited is going to, because we're doing breadth first, we'll visit all of the places that are 49, and then we'll visit all of the places that are 50. And the first one that we get is 51. We know all of those are before. So I think that's all it is. So we like do the same thing. I don't think this will finish it because this one took 82 steps, right? So we're definitely there. So we'll do this again. But we'll just say if steps equals 51, return visited.len. Like, I think that's all we do. Oh, I don't have my thing there. 139, is that right? It looks ugly over there. Sorry, I still haven't figured that out. Too high. Why would it be too high? How many locations, distinct XY coordinates, including your starting location, can you reach in at most? 50. Yeah, like this visited is going to add them all in, right? Get all my neighbors. Hmm. I insert these ones right here. That's the problem. Like my visited.lang contains my current neighbors. Right? Like think about the loop is when I'm on the 50th one, I find my neighbors, I add them to the visited insert. So my visited actually contains all of the 51st ones as well. Is it like minus frontier.lang? That doesn't change it. Really? My frontier is empty? So I could just do this. Does that give me another number? Still 139. Is it 135? Am I just counting wrong? Too low. Interesting. Okay, so what am I missing here? Am I really off by one? Eight more seconds. We pause. Is my thinking correct that it's just the visited list? Okay. So what did I have wrong there? Well, I mean, we got there. Am I just reading it wrong? At most 50 steps. Okay, so what is that part 2 saying? How many distinct XY coordinates, including your start location, can you reach in at most 50 steps? I mean, you start here. There must be some math. You'll have to help me out with some math. Maybe I can also ask some AI. Who should we do? Chat GPT today. In Erst. Maze generated formula solved via BFS. Yep, we got that. Good. Yeah, I did forget the favorite at the beginning. Count ones. Perfect. Modulus. So this is what I'm saying. That is multiple of 2. BFS shortest. Target. Start. Vecdeck. Start 0. Hash visited. Yeah, Q frontier. Same thing. Cop. So if I find the target, I quit. Otherwise... Oh, they use I-32 here that allow them to add the numbers. Oh, that is interesting. I can use I-size operations here because I'm not actually looking at something. I'm just computing its value. So what is that? The reason I did like this part right here was because I was thinking, oh, what if the point goes this way? Or what if the point goes this way? So I was using a U-size to like keep it bounded to the graph. But I don't actually have anything on the graph. The graph is like ephemeral or whatever. It's a computed graph based on this function. So I could just use I-size here and then do those checks. So that's something worth thinking about. Okay, so that solves it. BFS reachable. Max steps 50. Ooh, okay, so what's happening here? Is if I ever get past a 50, I skip it and then I just go through the queue. Like the way that I was doing it is I was saying, if I ever get to a step that is 50, I'm like done. This is the right way, right? So like finish the queue and then just return visited lane. So I hope that makes sense. I think it makes sense to me. Like what it's saying is, so any other previous step, you would then consult the neighbors and insert the visited, try and put it in the visited list, and then add the neighbors that haven't been visited. So those go on the queue. Once you start seeing ones that are 50, that's like terminal. So you stop at 50. So you don't go try adding neighbors anymore. You just loop through it, and eventually you get through the entire frontier list and you return the visited lane. Okay, this is the right answer. So I did kind of like messing it around, luck into it, I guess. But okay, I actually want to change this around. This number's always going to be positive. But so then this one we can do like what I was thinking about before. So it's like -1 0 1 0 0 1 0 -1 dot iter dot So I don't want to include the ones where self.x plus dx. No, I do want to include the one where that's greater than equal to 0 and self.y plus dy greater than equal to 0. And point new x self.x plus dx self.y plus dy dot wall favorite, I guess is where it's and not wall dot collect. Oh, I need to. Well, I guess I could just do this here. So I could, oops, map, because now I have eye sizes. So we also want to filter on P, not P dot wall favorite. That. Okay, that feels cleaner. Yeah, so why can I do this? Again, I don't have like an actual grid where I have to worry about like, I guess I could do like saturating subs and stuff like that. But anyway, this allows me to basically just say go through the possible ones, turn them into a point, only keep the ones where my X and Y's are greater than 0 and they're not a wall, and then I collect them. That looks cleaner to me, at least. And then this is like your standard, you know, salt thing. You'd add like right here, panic not found, because presumably you find it. Okay, and then yeah, P2 is we just say do the same BFS, but we terminate at 50. Like that's just the key point that was like that I wasn't following through with, was this part. So it's funny, it was like very close. Apparently the graph is like relatively small, like it was between 135 and 39, and then it's kind of got there. Okay, not too bad. A little bit tougher than yesterday, I think, but not terrible. So let me know how you did. What are the things that you did maybe changed or different? You could probably use the pathfinding library for this one. I don't know how you'd use it for this one. That might be interesting. Maybe there's some way for you to have this effect. Anyway, there you have it. Day, what is this? 13 in the bag. Thanks, everybody. See ya.